Alright, so this is the second example where we see that that this array would require the maximum number of passes to be completely sorted, right? So we have an array of length 4 and the elements are 4, 5, 6 and 3, and we are required to sort this array in ascending order, right? Now, we already know that the maximum number of passes required to sort an array of size n is n minus 1. Therefore, for this array, the maximum number of passes that we will require is 3. Okay. Now, I'm not going to explain the steps here because I've already done that with example 1. So I'm going to do this a little quickly. All right. I hope you don't have a problem with that. All right. Okay, so this is the first pass, and the elements of the array are 4, 5. Let me use a different color: 4, 5, 6, and 3. It is on a color change. 4, 5, 6, and 3. Don't need this anymore. Now, we always start comparing from the first element. Therefore, the value of g would start from 0, and the elements that will be compared are ARR 0 and ARR 1. 4 and 5 will be compared. 4 is not greater than 1, therefore they will not be swapped, and we continue on with our array, with our comparison. G would be 1, I'm going to compare ARR1 with ARR2, 5 will be compared with 6, 5 is not greater than 6, therefore they will not be swapped, so we continue with our comparison. The value of J will be 2, and ARR2 will be compared to ARR3, and therefore 6 will be compared to 3. Now 6 is greater than 3, therefore they will be swapped. Hence, let's show that they have been swapped. So 6 will come down and 3 will move up. Right? Because they have been swapped, therefore I'm going to put a star. And we have reached actually the maximum number of, now you see that the largest element has been placed in its correct position. There's no need to go any further. Moreover, we shouldn't go any further because there wouldn't be any adjacent element of 6, right? So the largest element has been placed in its correct position. And so this was the first pass. The next pass, this is going to be our starting line. Let me remove a few things. Just a second. Get rid of this, and let's make a copy of this. Alright. So this is our array, and this is our second pass. The value of I is 0. We start a comparison from the 0th element. The element at 0 will be compared with 1. The 4 will be compared with 5. 4 is not greater than 5, therefore no swap would take place, and thus we can move on with our comparison. Sorry, what just happened? Copy. The value of j will be incremented by 1, and the element at 1 will be compared with the element at 2. Just a second. Okay. So 5 will be compared with 3. Now 5 is greater than 3, therefore they will be swapped. Let's copy this. 5 would come down, and 3 would move up. 5 would come down, and 3 would move up. And we see that 5 has been placed in its correct position. Therefore, we can stop our comparison here. Alright. And we still need to move on with our next pass, that is the third pass. And this is the current state of our array. Let's copy this, get on to here, and copy this line. Alright. Now, this is the current state of our array. The 2 elements have already been placed in its correct position, and we are at our third pass, and the value of I is 2. Start a comparison from 0. 4 and 3 would be compared. We find that 4 is greater than 3, therefore they will be swapped, right? So 4 would come on. 4 would come down and 3 would move up. And we see that we require a total of 3 passes to sort this array, right? And the maximum number of passes that we require to sort an array of size 4 is 3, and we required 3 passes, right? Moreover, we did require 3 passes, but what was the last value of I? The last value of I was 2, right? Therefore, the maximum number of passes required is n minus 1, but the range of the value of I is 0 to n minus 2. Because you see, we wouldn't require any more passes. And in the third pass is the last pass, because then all the elements have been sorted. We do not require to go for the fourth pass because 3 need not be compared with 4. All the elements have already been sorted, and when n minus 1 elements have been sorted, the nth element is already placed in its correct position, right? So let's write down these observations next. So we don't need this. Let's delete this board. Yeah. Okay, time for writing down the observations. Uh, the pass number, which is I, runs from I equals 0 to n minus 2, where n is the size of the array. Alright, I can probably move this to the center. Yeah. Okay, I can move this. Alright. Right. Moreover, for pass number I, j would run from 0 to n minus 2 minus I. Alright, let's put a box beside and these two observations. These two observations would help us in writing our program. Alright, so this was the end of example 2 of the bubble sort technique. The next video we're going to see or have a look at the algorithm for the bubble sort technique. Okay, see you in the next one.